Hello guys. Okay, so carrying on with our Link series, we're going to look at now how to set up the inputs on your ECU. So these are things like oil pressure, crank, cam, digital inputs, any 0 to 5 volt inputs, and this is how we're going to set them all up. And again, we're going to be referring to our documentation to show us A, what we have, and B, where it's wired to, so we can know exactly what's going to happen. We've got the harness on here with all the sensors plugged in, so obviously we'll be testing as we go along to make sure that everything is working and it is correct. So going back to here, what we're going to do is I'm going to go through the first two. So crank and cam are set up as default inputs. So again, this is another really good resource, is the wiring information over here. Okay, let me just bring that in there. So what we can do now is we can go into, in our case, we've got the extreme header. So you'll see here we've got trigger 1 and we've got trigger 2. So these don't specifically need to be actually set up in the ECU. They are dedicated pins for that information, because obviously crank and cam sensors are quite important. So again, you don't need to actually tell it, the ECU, where they're plugged into. Effectively, you just got to make sure that all your information is correct, so that you've got the fact that it's an 8-cylinder, 4-stroke, etc. When you get to your triggers, you tell it that it's a 1UZ VVT-i in this case, because that's the closest to a 3UZ, and so on. So that's the important information in relation to that. So we did do a video on engine configuration, so you can go ahead and watch that, and that's where we went through setting up all of that information. Okay, so now that that's out of the way, what we're going to do is we're going to go back to our documentation, and we're going to start working our way down here. So obviously these are all output, shield ground, that we've already been through. And effectively now we've got, first one is analog voltage 4. So analog voltage 4 in our case is VPA2, so that's Toyota terminology. That's the sub signal for the pedal sensor, or accelerator pedal position sensor. So what I'm going to do is I'm actually going to group these together, because you set them up together. So I'm going to go down, and analog voltage 3 here is VPA. So that's our main pedal sensor, and analog voltage 4 is our sub pedal sensor. Okay, so going back to the software, what we're going to do is, obviously in this case we're using drive-by-wire. So in this case we want to go to electronic throttle. We want to go to eThrottle 1, because again we're only using one throttle. Now what we can do here is you'd go and you'd open up the eThrottle setup, and it would put it into setup mode. This would then allow all the options to open up for you to put in your TPS and your pedal position sensors. Okay, and what we'll do then is we're going to go over to accelerator position sensor, and you'll see at the moment we've got APS main source and APS sub source none. So the ECU doesn't know where they're connected to. So what we're going to do now is we're going to go into main, and we know the main is analog voltage 3, and we'll just save that over there. And we're going to go to the sub, and we're going to go, that's analog voltage 4. Okay, now when you obviously open these up, you're going to have a bunch of options that are going to come available now. Now these are means of telling whether there's an error with the sensor itself. So you'll see you've got a low value, which will determine that the ECU is in fault by being low. And you've got a high value, so it'll tell you if it goes beyond a certain point that you're going to be too high. Okay, so effectively if you come down to here, this little screen over here, so I'm just going to move this around so we can actually go through and we can get this all set up, because this is what we're going to be mainly dealing with, as well as digital inputs over here, which are absolutely fine. So, and by the way, sorry, you just click on these little arrows here, and then effectively you can then resize the screen. Okay, so now that we've actually allocated there, you can actually see we've got APS main source voltage and we've got APS sub source voltage. Alright, so now you can actually see the voltages there. So now what I'm going to do is, if you watch these two voltages here, I'm going to move my pedal down, and there you go. So you can see they're traveling between, the main is 0.79 all the way up to 3.71. The secondary starts at 1.57. Let me just move that out the way a bit better. And works its way up all the way to 4.5 volts. Okay. So now we know that that's working, so we're absolutely happy with that. And we know that if it drops below these values over here, so what I'm going to do now is I'm actually going to unplug the pedal. And when I unplug the pedal, you should see those values drop down to 0. So, sorry, just give me a second. So there you go. Now the second that happens, you see now there, we've got two fault codes. So it says analog voltage 4 and 3 is below error value, because now they've dropped to 0 volts. Okay. As soon as I plug the pedal back in, you'll see our voltages shoot back up again. Now once the error code is obviously input into the ECU, you actually have to go into event log here, clear fault codes, clear the codes, and there you go. So now we have no more codes anymore, because I've plugged the pedal back in. Okay, so we're happy not only that it works, I'm happy that it's actually wired to the correct thing because I'm using the pedal, and I've unplugged it to make sure that when I do, those go away and we get our error code, so we know the check engine light would come on and give us the codes for those when it does happen. All right. This thing underneath here where it says APS sub 100% of main, I'm not going to go into that in this one. That is reserved for the drive-by-wire one, so do feel free to pop over and watch that video. We'll go through that when we set up the drive-by-wire. Okay, so now we've got those set up. We can see it there at the bottom. And obviously when I'm setting it up and you can see when we're choosing what input we're using, you'll see it actually populates there so you can see what you've already set up. All right, so going back to our documentation now. Obviously, we're going to go down here, and we've got next one is temp 1 or analog temp 1. Now, we've got THW. That's a Toyota terminology again. That stands for temperature hot water, I assume. Not asked them. But anyway, so you're going to come across various different things. People refer them to as CLT or coolant temperature. Link refer to it as ECT. So that's engine coolant temperature. So check with who's ever done the documentation for you. They may have a different terminology, but those are the major ones that you're going to come across. So in this case, we're going to jump over to our software again. Now, most of the analog inputs we're going to find are going to be right here under the heading analog inputs, funnily enough. So now we're going to be looking at ECT. So as I said, link is engine coolant temperature. When we get in there, you can see source at the moment is none. And you'll see there, you see now we've already assigned those. They're available there. So you click on analog temp 1, you click OK. It'll be in blue because we haven't stored it to the ECU. So I press Control S, it stores it to the ECU and becomes permanent. Now, obviously, once you put that on, all of these options are going to drop down. Now, first of all, before I get into anything else, when you come to temps 1 and 2, what you'll notice is you can adjust the pull-up resistor. Okay, what I mean by that is you can either turn it off, you can have a 1 kilo ohm pull-up resistor, or you can have a 10 kilo ohm pull-up resistor internally in the ECU. Okay, now this is important because if you have a particular sensor, let's say you got a coolant temp sensor from a car that you need a specific pull-up resistor. So let's say the documentation says I need a 3.5 kilo ohm pull-up resistor to 5 volts in order for this temperature sensor to work properly. You're going to have to remember that you're going to have to put those sensors into analog temperature 1 and 2 because analog temperature 3 and 4, which we have in our case here on an extreme, they're actually locked, which we'll get to in a minute when we do 3 and 4 because we do have 4 temperature sensors in this harness. But you'll see that says there it's locked at 1 kilo ohm. So the important thing is you can't turn it off, and B, you can't change it. So if you need a very specific resistor for your sensor, make sure you use analog temperature 1 and 2. And while I'm busy here, I'm just going to go over to here. This is a help browser that you can open up within your software. It's incredibly useful because as you click on certain things, it'll actually tell you exactly what it's all about, and it has a little help function that you can read through. Okay. So that's basically very helpful at any time when you go as you're going through the things over there. So when we're looking at analog temperature error value, low and high. So again, at the moment you can see down here now, I've actually got analog temperature as engine coolant temperature voltage. So you can see I've got it plugged in. So it's 3.51. Now obviously here you can see now it's actually giving me a temperature. But what we want to check at the moment is we want to have an error if basically the sensor stopped working. So at the moment we've got the error set to 0.05 volts when it's, if it goes below that it'll throw an error. And we've got it set to 4.94 volts if it goes above that to give you an error. So effectively, because you have a pull-up resistor inside the ECU, it's going to pull itself up to 5 volts. It might not go all the way. But what I'm basically going to do is you can see the voltage down here is 3.51. I'm actually going to pull the coolant temperature sensor out, and you see there it goes to 4.94. Okay. As standard, the ECUs, when it comes out there, it'll say 4.95. So if I set it to 4.95, right, and I'm going to store that in the ECU. Now again, once the error is gone, I have to go in and I have to clear the ECU fault codes, come back again. There you go. Everything's happy. We've got no fault codes. But now, if you watch the voltage down here at 3.48, I'm going to pull that up. It's going to only go to 4.94. So if I do that, I'm not going to get an error. So I'm not going to know if there's a fault with my coolant temp sensor. Okay. So just make sure that when you're setting these up, that you do pull them out and make sure that you set this value correctly. So I know that it needs to be 4.94 volts in order for the error to actually occur. Okay. The other thing that you can do as well is you've got an error value. Okay. So effectively what this means is if it errors out, where is it what value is it going to input into the ECU. Now, obviously, if your engine coolant temperature sensor goes off, it's not ideal, but you may not want it to actually, stop the car from driving or whatever, but you also may want it to go into some sort of default mode. Now, as standard, if you look at the Toyota software on OBD2 diagnostics, you'll see that in relation to temperature sensors, they obviously default the value to minus 40 degrees. Okay, so that's effectively what happens there. And what I mean by that is now, if you look down here, I've got ECT as 22 degrees. If I pull that out, you'll see it errors to minus 40. Okay, and you're asking, well, what does it matter? What does it matter error to? So you can still carry on driving if your coolant temperature sensor goes off, but it may be a problem that's causing it. And if you have your intake air temperature adjustments done on that, then what you can do is if you set it to something low like minus 40, what it'll effectively do is it'll make the car run rich. Okay, rich engines obviously running effectively a little bit cooler than lean engines, so effectively you might want to do that in order to get it to run a little bit richer than what it normally would, because it would take into account those coolant temperature adjustments to the fueling table. All right, so again, this is completely up to you. Some guys would just have it say go to 20 degrees because they know that that would be running fine. Some might have it go to 80 degrees so the engine just carries on running exactly as you would. Okay, so again, this is completely up to you. You can decide, what you want to do in relation to that. Right, I'm just going to clear the fault code so that will go away. Okay, next thing you want to do is the calibration. So I'm going to go through this now, and I'm not really going to do it on the other sensors because effectively we're using similar sensors on all of them. But effectively, this is where you're going to choose what calibration you're going to use for the sensor. All right, so we're using the Toyota default coolant temperature sensor on our 3UZ, and I tend to find that the Bosch NTC readings give you the most accurate in terms of that. So at the moment you see here there is no specific Toyota sensor on here, but through my experience Bosch seems to work absolutely fine, so that's why I choose the Bosch. Now, what if you have a sensor that isn't on the list, and let's say you try Bosch one and you use another sensor to sanity check yourself? Okay, not a problem at all. If you come down here under analog inputs, you can go to calibration tables, and you've got quite a lot of calibration tables you can work with. So remember, things like temperature sensors are not a linear calibration. You might find your map sensor is a linear calibration, or a pressure sensor is a linear calibration. What I mean by that is it's 0.5 volts is atmosphere if it's a gauge pressure sensor. So 0.5 volts is atmosphere, and if you looked at the graph on the settings that the manufacturer sent you, it'll be a straight line all the way to 4.5 volts. So let's say you had a 10 bar sensor, 0.5 volts would be 0 or atmosphere, and then 4.5 volts would be 10 bar. Okay, so that's what a linear calibration looks like. When you have temperature sensors, they do not have a linear calibration. It looks much more like a curve. All right, so that's when you would use one of these tables over here. So again, you can give it a label. You can tell it what input units are. So let's say we're doing a temperature sensor. You can again choose, okay, sorry, not what actually, I mean, output units are what you can choose from there, but you're going to go and work on here. So if you only have ohms available to you to set it up, you can use that. If you have volts available to set it up, you can use that. And again, here, you can tell it what type of sensor it is. So is it temperature, pressure, lambda, percentage, mass airflow, distance, volume? You can go and pick from there. And then importantly, then you're going to go to your calibration table. And then what you're going to do is you're going to go to your axis setup over there, and then you're going to tell it exactly what it is. So in other words, in this case, we want input to be as voltage, and then we can change the other axis to give us a value there, and we can fill in all the details for that. Okay, so that's how you would set your own calibration table. That you'd have to get from the sensor manufacturer itself, and then you'd have to fill in all the details there based on what you're working with. Okay. Now then, once you've actually got that particular calibration in there, you'll see from the drop-down list, you can now choose cal table 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, or linear cal 1, 2, 3. So again, you just go ahead and you pick exactly which one you want to use, and each one you can give a label, basically a name. So you can give it a name. Okay, right, so that explains the calibration. So I'm not going to go through that again. I just want to get through that, have you understand exactly how that works. We'll obviously choose the sensors that are relevant to our thing, and luckily they are all in the drop-down list. Okay, and so basically what we are going to do next is we are going to refer back to our documentation, and we're going to go down and we're going to have temp 2. So this is now temperature hot air, or THA is the Toyota terminology. Again, mainly you're going to be referred to as IAT, or intake air temperature sensor, and that again is what Link refers to it. So again, you need to check with the person who provided the documentation how they assign terminology for whatever inputs they're working with. So in our case now, what we're going to do is we're going to go to IAT. So again, source is nothing. We're going to go into analog temp 2. We're going to store that. So again, we've got our values there. So what I'm going to do now is I'm going to go down to IAT at the bottom here. And what I'm going to do is I'm going to unplug my intake air temperature sensor. And I'm going to see that that defaults to 4.94. Fantastic. Okay, so again, just going to change this value here to 4.94. Store that in there. And again, what we're going to do is we're going to leave the 1 kilo ohm pull-up resistor, because that's what the settings of the actual device. So this, we are using an actual Link intake air temperature sensor. So again, it's the IAT 1-8. So again, we'll choose that, and that'll give us our correct thing. And again, we can choose the error value. So in this case, if we wanted to mimic Toyota, there you go, minus 40 degrees. So you see at the moment, the IAT is reading exactly the same temperature as the coolant temp, and that gives me hope, because obviously we know the calibration is correct on this one, so hence I've used the Bosch calibration on the Toyota sensor, and you can see the values are pretty much perfect or within a tolerable amount, so 1 degree is absolutely fine. Okay, so that confirms that for me as well. So it's always good to do a sanity check. If you have, like say, 4 temperature sensors in this case, but you have one, for instance, in this case, we know it's a Link sensor, so we can plug it in, put the calibration in, lay it on the bench here. If we're getting 21 degrees on the Link sensor and we do the calibration for that and it gets to about 21 degrees, you can be pretty confident that you are, have the right calibration. You will have to check it, obviously, if you don't have like a data sheet to work from, but it gives you a good starting point to work from. Okay, so moving along, what we're going to do now is we're going to carry on down here. Okay, so we've got analog voltage 1. So VTA, again, this is Toyota terminology, but that's TPS. So that's our main TPS signal. And again, we know that's drive-by-wire, so we know we've got 2 TPS signals. So I'm going to come down here to analog voltage 2, and we've got VTA 2. So that's our sub. So analog voltage 1 is main TPS. Analog voltage 2 is sub TPS. So again, we're going to come down to here. We know that it's in the electronic throttle heading, because there it is, throttle position sensor over there. So again, we're going to go to here, TPS main source and TPS sub source. So we know that analog voltage 1 is main, and we know that analog voltage 2 is sub. So we're going to save that. And again, we're going to do exactly the same thing, or again, you've got your error values down here, and you can calibrate those exactly as you want. I do have a throttle on here, but I'm not going to actually press it open now for the time being, because I think you guys understand exactly what these work like. I'm not going to go into the rest of this, because it's obviously calibration for the throttle itself. That is covered under the drive-by-wire throttle. So this is just putting the physical actual inputs for TPS in and make sure that they are correct. And you'll see here that I've got TPS main there, 0.79, and TPS sub. And you know what? I'm just going to open it up anyway for you, so you can see there that it's climbing. Okay. And you see there it goes. Okay. I'm not going to go into detail, but what you'll notice is the sub signal is actually peaking before the main signal peaks out. So you see I can go all the way down there, and then eventually you'll see that second sub source starts to go down. Okay. I do go through that exact explanation on the drive-by-wire setup and how that works. So please, again, if you want to watch that, just find it in the playlist for Link engine management videos that we've done. Right, so moving on to the next one, we've coming down here. So we've done analog voltage 1, analog voltage 2 we've done. Okay, digital input 3 is STA. In my case, that's just a starter signal. So it's a 12-volt signal when the actual car is cranked, and that effectively tells the ECU that you are cranking it. Now, the reason we do this is there are some functions and features that you can use when you're cranking, and if the ECU knows when the car is cranking, obviously then it can activate those features. So what we're going to do now is, this is a digital input, so this is where we actually just literally supplying 12 volts to the ECU when that thing is actually active. So in this case, we're going to go to digital inputs now, and obviously they do have a predetermined list of items that you've got there. So you can have things like oil pressure switches, power steering switches if you have some of those, your ignition switch if you're using like an ECU hold power. So some vehicles have stepper motor type idle control valves. And so you can wire the ECU to stay on for a few seconds after you turn the ignition off to allow things like stepper motors for idle control to actually reset into their default position. So that's why you would use something like that. You can have a clutch switch in there. So obviously, people who want to do maybe two-step or launch control, etc., you can use a clutch switch to do it there. You can have two brake switches. So on the Toyota systems, on the standard vehicles, they actually use that particular setup. So they'll basically have a 12 volts when the brakes are not pressed, and they'll have a 12 volts when the brakes are pressed. So the ECU can know the exact state of the brake pedal and what's going on. Okay, so that's useful for things like cruise control. So the ECU knows when the brakes are not pressed, but it also knows when they're pressed. And obviously you can use that then to switch off the cruise control if you press the brakes like a normal vehicle. Okay, so in our case we want to do the start position. Again, source is obviously off because it isn't down there. So we want to do DI. Let me just check here. Digital input 3. All right, so we're going to go digital input 3. Now, obviously, we don't want to use a pull-up resistor because we're supplying the ECU with 12 volts. So if we were grounding it out, so let's say the signal was a ground coming into the ECU. So let's say you had a switch in your car that you wanted to switch on, so just taking an example here, log marker key press, okay, or lock timing switch. So let's say you want to lock the timing and you have a switch in your vehicle and do that. So what you would do is, to avoid having loads of 12 volt signals around your vehicle, what you would do is you'd ground the switch out on the other side and you take the other side over to the ECU. If you're using a ground, what you would then do is you would put the pull-up resistor on, because what you want the thing to do is you want it to float at a voltage, and then when you provide the ground via the switch, it'll pull it down to 0 volts or ground it out. Okay, in our case, we're not actually supplying a ground, we're supplying a 12 volts, so we're not going to use the pull-up resistor. And again, this is all written down here, so I'm just going to go through it as best I can, but again, if you're ever actually on the thing, this is incredibly helpful. I cannot emphasize enough how much use this is. Everything is in there for you. All right, so again, now I've just said we are supplying a 12 volt signal, so obviously our active state is going to be high. So let's say if you were providing a ground, you would then activate the pull-up resistor to get the output to float at 12 volts, and then effectively when it went to ground, you would then be activating the actual input. And so what I would do is I would choose the active state as being low. Okay, so in our case, we're going to go high. Okay, and latching is, well, it's effectively, so I press the button once, it'll stay on. So if you have like a momentary switch, you can press the button once, it'll stay on. If I press it again, it'll only turn off when I press it again. So in this case, we don't want that because effectively it's a start signal. We just want the start signal to work while the actual thing is engaged. So what I'm going to do now is just to test that actual input out. I'm just going to quickly provide the start signal on our harness with a, oh, hang on, knock that one out. Okay. All right, give me a second. I'm just going to close that down. No. G4X. Right, okay, fantastic. I do apologize about that. So, right, so I'm going to now activate our start signal on our ECU, and what you should see now is you've got digital input start position is inactive, and if I hit that over there, see there, now it's active. Fantastic. Okay, so I'm happy with that. I know that works exactly as it should. So again, this is basically for, there are certain features that you can do if the ECU knows when the vehicle is cranking over. This is not the video for going into stuff like that. This is just obviously setting up the input. So we're going to move on to the next one for that now. So coming along here, we've got digital input 3 is STA. Coming down, coming down. Okay, so digital input 1 is our cam sensor for our left bank intake cam, and digital input 2 is our cam sensor for our right bank intake cam. And obviously this is to do with the VVT system, VVT-i system. Okay, so in terms of how to put that in, what we're going to do now is we're going to go to VVT-i control. So again, it's not in digital inputs, it's under VVT-i setup. So what we're going to do is we're going to select 1UZ VVT-i. So again, as per the triggers, the 1UZ and the 3UZ are identical. They have the same trigger pattern on the cams. for the VVT-i in relation to that. They have the same solenoids, everything's exactly the same. So you can choose one UZ VVT-i and it'll cover both of them. Okay. So basically, again, I'm not going to go into too much detail about VVT-i. We'll do a video on that when we have an actual engine running properly on a stand and so on and so forth, because obviously I can't show you exactly how it works. But effectively, if you want to have a quick read through, you can just have a look through over there. It is quite simple. Things like this, like the RPM lockout, basically says do nothing until you reach a certain RPM. So again, in this case, it's 1200. You may want 1000 RPM because most VVT-i systems use oil pressure. So if you are using oil pressure for your VVT-i, you don't want it to activate at like 500 RPM or 800 RPM because your oil pressure is going to be very low. So what you want to do is you want to say, okay, pick a certain RPM when you know the oil pressure is going to be enough, especially when it's warm, to actually activate the solenoid. Otherwise, you're going to be wasting your time. And again, this is quite simple. ECT lockout. So effectively, it's not going to do anything with the actual cam VVT-i until it reaches above a certain temperature. In this case, 50 degrees. Absolutely no problem. All right. So again, I'm not going to go into too much detail about this. This is more of a separate video on its own. It is a complicated subject, not a complicated subject, but it does require a video of its own. So we're going to get back to what we were doing, which is effectively we want to look at inlet bank 1. So on a 3UZ, bank 1 is the left bank. So if we throw back to our documentation, we know that the left bank sensor goes into digital input 1. So we're going to go there. So cam sensor input is digital input 1. So we'll store that over there. Now, in our case, we've got a variable reluctor sensor. So we're not going to use the pull-up resistor. That's for if you have like a Hall or opticals type of sensor. The active edge, this is going to be depending on how you wire the cam sensor up. If you wire it per standard Toyota diagrams, you need to select falling edge. Okay. Again, it's another video on falling and rising edges, etc. But there are loads of videos around if you want to have a look at that. You can see guys like HPA Academy have done loads as well. All right. In this case, the PWM output, what they're basically referring to is the actual oil control valve. Okay. So in our case, I'm going to set this up now. It'll be for part of our output section. But basically, if you look down here, we've got oil control valve left bank. So that's going to be auxiliary 1. Okay. All right. So again, moving on to the next bank, we're going to go to inlet bank 2. We know this is digital input 2 is going to be this one. And again, we're going to store. Again, no pull-up resistor because it's a variable reluctor sensor. Falling edge because we've wired it as port Toyota. And we know that auxiliary 2 is the oil control valve related to that cylinder. So again, auxiliary 2, oil control valve, right bank. Okay. So that's all set up now. So what we're going to do is we're going to move on to our next values, which is now we've got digital input 1 and 2, 5 volts, analog voltage 3 we've already done. Okay, moving on to the next one down here, we've got, all right, okay, so now we've got temp 3, which is oil temp. So in this particular case, the customers opted to have Bosch combined pressure and temperature sensors. So in this case, we're going to set up the oil temperature now. So again, we're going to go to analog inputs, and you'll see here ever so nicely, there's oil pressure and there's oil temperature. Okay, so what I'm going to do is I'm going to go back to my list so we can do it all in one. So we know temp 3 is our oil temperature. And coming down here, we know analog voltage 6 is our oil pressure. Okay, so analog temperature 3 oil temp, 6 oil pressure. So going to oil temperature, we know that's analog temperature 3. We'll save that over there. So you see, this is what I was talking about. If you look here now, this is locked. So it's a built-in 1 kilo ohm pull-up resistor, set in stone. You can't turn it off. So again, you need to make sure that whatever sensor you're using, you're going to be happy with the 1 kilo ohm resistor. If you need something else, you need to put it on temp 1 and temp 2 to be able to turn it off and put your own value in. So again, these are exactly the same. You can just pull it out and test it over there. But as you can see now, I've got oil engine temperature, 3.43 volts. I've got oil temperature here showing 23.2 degrees. And I know this calibration is correct because this is the one for the Bosch combined pressure and temperature sensor. And what I'll do now is I will find the oil pressure. Here it is. Okay. So just to make sure everything is working as it should, I'm going to unplug it. And you see straight away there, it's gone all the way down to minus 40. And you can see the voltage has dropped or gone up to 4.94 volts. And I can put it back in there, and there you go, 21, 22 degrees. So again, it's within a degree effectively of what we've got on there, so we're quite happy with that calibration. And again, we can change the error value if we want to from there as well. Okay, so now we want to go to oil pressure because we know that's analog voltage 6. So we're going to go to analog voltage 6 and we're going to set that up there. So again, same things, you got your error values, you got your error value down there. Again, it'll go through all of there, and we know that it's the Bosch 10 bar sensor. It's the combined pressure and temp sensor, part number ending in 340. So now that I've allocated that, obviously we've got pressure 0. Now I don't know if I'm going to be able to, so do bear with me, but I'm just going to basically blow into the sensor, and you should actually see that go up a little bit. Okay, I haven't got the strongest set of lungs on me, but you could see the actual value going up there, and you could see the actual voltage change there from 0.47. So as I said, usually with these types of sensors, it goes from like 0.45 all the way to 4.5. I can't blow 10 bar of pressure, so I won't be able to get to that top value. But again, nice and simple, just change these values over there. So what you can do is just pull out the sensor. Okay, and you can see oil pressure goes straight down to 0.02, which is within our value over there. And again, you can see we've thrown an error code for oil pressure signal. Okay, so that is working exactly as it should. So I'm just going to go into event log. I'm going to clear the fault code, and we're back to normal again. All right. Okay, so that's oil pressure and oil temperature set up in one go. So moving down to temp 4, we've got fuel temperature. So again, because they're combined sensors, let's do them all in one go. So we've got temp 4 is fuel temp, and we've got analog voltage 7 is fuel pressure. So referring back to here, you can see here we've got fuel pressure and we've got fuel temperature. So starting with fuel temperature, we know that's analog temp 4. Again, exactly the same thing. I don't have to repeat myself over and over again, but this has got an error value of 20 degrees. And again, if I now come along and unplug the fuel temperature, so going down here, you can see we've got a voltage value. And if I unplug the sensor, you'll see that it shoots up to 4.94. So what I would do in this case is just change that to 4.94. So again, I do recommend doing this when you get it on your side, even if someone has done it for you, just to be on the safe side, just to make sure that you will get an error code the second that the sensor's unplugged or it goes faulty. Okay, it's helpful for you. You can see it straight away. All right, so that's that one. So now we're going to go over to fuel pressure. We know that that's analog voltage 7. Store that in. Again, same thing with these values over here. We've got Bosch 10 bar, which we know is the correct sensor. Pull that out, and straight away, there you go. Now we've got a fault, so you can see that fuel pressure has dropped to 0.02 volts, because obviously it's not connected anymore. And there you go. Now we're back, and we'll go clear the fault codes there. All done and dusted. All right, again, no errors, fantastic. All right, so working our way down here, we've got fuel temp over there. Okay, we've done oil pressure, and we've done fuel pressure. And carrying on. We've got the analog voltage 5 map sensor. So just these auxiliary ones, the customer has a 12-pin DTM plug. So any unused inputs and outputs, we do take to an auxiliary plug on all of our harnesses. So it just means that if the customer wants to add something in later, it's much easier to do it like that. Okay. So again, now we're going to go to set up the map. So we're going to go over to map. Again, source is none. We're going to set that up as analog voltage 5. We'll store that in there. So again, we are using a Link 1.15 bar map sensor because the car is naturally aspirated. So we just choose it from the drop-down menu. And again, what we're going to do now is just to check that it is actually working and we've got everything wired correctly. We're going to refer to, there's our map sensor. We've got 4.01 volts. And you can see we drop straight down to 0.02 and therefore activating an error. Okay, so just going to clear the error codes here to get rid of that. No errors, fantastic. All right, so slightly different on this one. You've got a map sensor calibration button. So I do recommend doing this every time, but effectively it's really nice and easy. You click OK to calibrate and it carries out the calibration. Okay, so if I go over to our tuning screen over here now, you'll see that we have got our, where is our, let's just add on map sensor onto here. So we go into properties. Sorry, this is where you can actually custom make your own particular ones. And in this case, we want to go to map. We want to add that in. Click on OK. Bring that down to include it there, and you'll see 101, or basically atmospheric pressure. Alright, what I can do now is, again, I'm just going to try this out. I'm just going to suck on the sensor just to create a vacuum, so just bear with me. So as you can see there, I'm just sucking on the sensor a little bit just to create a vacuum, and I can check that it is actually going up and down. So again, these are things we're doing. We're just on the bench here testing it out. But you can do exactly the same at home on your engine when you're carrying out there. And now you'll see that all the stuff we've added in here is now actually set up on this little analog map there, so we can see exactly what everything is doing. We can check what our voltages are for everything, and I've set this little table up here so we can see what's going on with all of our voltages, actually giving us data, so things like 21 degrees C or 20 degrees C, etc., and giving us TPS main and sub. Obviously these are not calibrated yet, so that is that is basically incorrect. But again, I'll refer you to our drive-by-wire video in relation to that. I'm not going to cover that here. But we'll go back to our thing and make sure that we are 100%. Okay, so we've been through our list. We've got everything set up there. We can run through and make sure that we're happy with everything. We can confirm that analog voltage 8, 9, 10, and 11 are not connected. And if I go here, I've got analog voltage 8, auxiliary 9, auxiliary 10, auxiliary 11, auxiliary. Absolutely fine. We've used up all our AN temp signals, so those are all connected and allocated and working and giving us values that we're happy with. And we know our start position indicator works, and obviously these would require a running engine to show you the signals that they're giving out, but obviously we know that they are assigned to that particular thing that we want them assigned to. Okay, so that's basically it. Now obviously I've just gone through the sensors that we've allocated to this engine. You may have less, you may have more, you may require, let's say you've got like an external lambda sensor. You'd obviously put that into your analog inputs, and again, nice and easy, they've got lambda 1 and 2 there pre-done for you. Okay, next up we're going to do a video on some very, very, very basic CAN, and I do mean extremely basic. We're not going to do any sort of complicated stuff with that, but it's basically going to show you how to activate the CAN, how to get the streams working, and depending on what devices you're using. So I'm going to finish this video off here. It has been 37 minutes. I do apologize for taking so long, but it is a lot to go through. But yeah, I'll get this finished now. Let's go over and let's start looking at the CAN data and setting how I set that up. So thanks for watching. If you have any questions, if you stayed this far through the video, well done. But if you have any questions, do fire them away in the comments, or again, you can find us on Phoenix Engine Management on our Facebook page, and you can fire us a message over there. So thanks for watching, and we'll see you guys soon. Bye-bye.